Today, we're taking a trip to the Pacific Northwest to talk about one of the most stunning mountains in the United States, Mount Rainier. It's this massive, snow-capped giant that looks super peaceful, right? But what if I told you there's something strange happening just beneath its icy surface? Stick around because we're diving deep into the hidden geothermal anomalies of Mount Rainier. And trust me, it's a story you won't want to miss. So, picture this. You're looking at Mount Rainier, this majestic, postcard-perfect volcano. It's covered in more glacial ice than any other mountain in the lower 48 states. It's beautiful, it's iconic, and for most people, it seems like a sleeping giant. But here's the thing about giants. Even when they're sleeping, they can still stir. Scientists have been keeping a close eye on Rainier, and they've found some pretty interesting stuff happening that you can't see from your hiking trail. We're talking about weird heat spots and melting ice that have nothing to do with a sunny day. These aren't just random occurrences. They're what scientists call geothermal anomalies. Let's break that down. Geo means earth, and thermal means heat. So, we're talking about unusual heat coming from inside the earth, right under the mountain. It's like the volcano has a bit of a fever. Now, this doesn't mean Rainier is about to blow its top tomorrow. It's way more complex and, frankly, way more fascinating than that. To understand what's going on, we need a quick geology lesson. Mount Rainier is a stratovolcano, which means it's built up of layers and layers of lava, ash, and rock from past eruptions. Deep beneath it, there's a chamber of magma, molten rock. This magma is the engine that powers the whole system. It heats up the surrounding rock and any water that seeps down from the surface. Sometimes the superheated water and gas find a way to escape, creating things like hot springs or steam vents, which are also known as fumaroles. Now, on most volcanoes you can find these features pretty easily. But Rainier is different. It's wrapped in this thick blanket of ice and snow. So instead of seeing steam vents puffing away on the rocky slopes, the heat is often trapped beneath the glaciers. This is where things get really interesting. Scientists have been using advanced technology, like thermal infrared cameras mounted on planes and satellites, to get a heat map of the mountain. Think of it like putting on thermal goggles and seeing the world in shades of red and blue. And what they found is pretty wild. There are distinct hotspots near the summit, particularly around the east and west craters. These areas are significantly warmer than the surrounding terrain. In some places, the ground is so warm that it's actually melting the glaciers from the bottom up. This creates hidden caves and tunnels within the ice, carved out not by water, but by the Earth's internal heat. Imagine a labyrinth of ice caves with steam rising from the rocky floor. It's like something out of a fantasy movie, but it's real, and it's happening right under the ice cap of Mount Rainier. One of the most famous examples is the Summit Crater Caves. These are a network of passages that have been explored by scientists and climbers. Inside, you can walk on bare volcanic rock while the walls, floor, and ceiling are made of shimmering ice. The air is warm and smells of sulfur, that classic rotten egg smell that tells you volcanic gases are present. It's a direct window into the volcano's plumbing system. The heat that forms these caves is a constant reminder that Mount Rainier is an active volcano. It's not dead, it's just dormant. It's resting. So why should we care about a few warm spots and some ice caves? Well, these geothermal anomalies are more than just a cool scientific curiosity. They are a critical clue about a potential hazard that is unique to heavily glaciated volcanoes like Rainier. This hazard is called a lahar. A lahar is essentially a giant, fast-moving mudflow. It's a terrifying mix of water, volcanic ash, rock, and debris that can flow down river valleys at speeds of up to 50 miles per hour, destroying everything in its path. Here's how the geothermal heat plays into it. The constant melting of glaciers from below by this volcanic heat can make the ice unstable. But the bigger concern is what happens if the volcano's activity increases. If there's a small eruption or even just a significant release of heat and gas under the ice, it could cause a rapid, catastrophic melting event. Suddenly, you have an enormous amount of water released all at once. This water would mix with all the loose rock and ash on the volcano's flanks, creating the perfect recipe for a devastating lahar. And here ends the scary part. You don't even need a full-blown eruption to trigger one. Sometimes the sides of a volcano can become weak and altered by the hot, acidic gases rising from below. The rock essentially gets cooked and rots from the inside out, turning into a soft, clay-like material. A large-scale collapse of one of these weakened sections could also fall onto a glacier or mix with river water, generating a lahar without any magma ever reaching the surface. This is what volcanologists call a sector collapse, and the geothermal activity we're seeing is a key factor in creating this instability. The communities built in the river valleys around Mount Rainier are well aware of this risk. Towns like Orting and Puyallup are built on top of deposits from ancient lahars. Geologists have mapped these old flows and know that future ones would likely follow the same paths. Because of this, the area has one of the most advanced lahar warning systems in the world. Sirens are tested regularly, and evacuation routes are clearly marked. It's a constant reminder for the residents that they live in the shadow of a powerful, active volcano. Scientists at the Cascades Volcano Observatory are constantly monitoring Rainier for any changes. They use a whole network of instruments. Seismometers listen for the tiny earthquakes that can signal moving magma. GPS stations measure any swelling or bulging of the mountain's surface. Gas sensors sniff the air for changes in the chemical composition of volcanic gases. And of course, they continue to monitor those thermal anomalies we've been talking about. Each piece of data is a small part of a very large puzzle, helping to create a picture of what the volcano is doing in real time. The research into these geothermal features isn't about fear-mongering. It's about understanding. It's about being prepared. The more we learn about how Mount Rainier works, how its heat interacts with its ice, the better we can forecast its behavior and protect the people who live around it. These hidden heat signals are like the volcano's pulse. By keeping a finger on that pulse, we can be better prepared for whatever the future might hold. So, the next time you see a picture of Mount Rainier, looking all serene and majestic, remember what's happening beneath the surface. Remember the hidden world of ice caves and steam vents, a place where fire and ice are in a constant, slow-motion dance. It's a powerful reminder that our planet is a dynamic and ever-changing place, full of hidden forces and incredible beauty. The story of Mount Rainier isn't just about a potential threat. It's a story of science, discovery, and the immense power of nature. Thanks so much for watching and exploring this incredible topic with me today. It's truly fascinating stuff. If you enjoyed this deep dive, don't forget to hit that like button and subscribe to the channel for more adventures into the wonders of our world. Drop a comment below and let me know what other natural phenomena you'd like to learn about. Stay curious, stay safe, and I'll see you in the next video.